So now we have two more standard forms for the equation of a parabola, and these are different now because we're looking at a vertex that is not at the origin but centered at some other ordered pair. We'll call it HK. If we're centered at HK, it changes our equation a little bit. We're going to open up our x variable to be now an x binomial, quantities squared, where we have the h value, which is essentially the x value of my vertex nested with the x variable. The y value of my vertex is going to nest with the y variable. And anytime my x variable is the one that's being squared, then we're talking about a parabola that is either opening up or down. Now we're depending on whether or not the a value is positive, will open up, or a value is negative, will open down. And again, this is a parabola where the x variable is being squared. Now if y is being squared, that implies that we have a parabola that's going to be opening, to the right or to the left. Depending on the value of a. If a is positive, we'll open to the right. If a is negative, we'll open to the left. And again, we have the x variable, or the x value of the vertex, nested with the x variable in the equation, but this time it's happening over here. So long as it's nested with the x variable, that is the x value of the vertex. So long as it is nested with the y variable, that is the y value of the vertex. And if y is being squared, then we're opening to the right or to the left. So again, we'll just make a note here that the value of the latus rectum is essentially the length of the segment that passes through the vertex point of the parabola, or through the focus point of the parabola. The length of that latus rectum is going to be 4a passing through the focus. So we're looking at an example here. We want to graph this parabola, and we want to find the vertex, focus, directrix, and the length of the latus rectum. Okay. Well, noticing that the y value is squared, that tells me automatically that it's either going to open to the right or to the left. And also noticing that we have a negative 8 as my coefficient on the outside of my x binomial, that implies that I'm going to be a parabola that's opening to the left because my a value is going to be negative. Now, we are interested in determining what exactly is that value of a. So I do want to rewrite this equation a little bit so that I can see what my value of a is. So I'm going to write y minus 3 quantity squared. I'm going to peel out the 4 that is part of the standard form of the equation. I'm going to peel that out. So this is going to have to be 4 times, well, it would need to be 4 times negative 2 in order to give me the negative 8 that's part of the equation. And then x plus 2 is my binomial that's hanging out over there on the side. So rewriting our equation like this enables me to see that my value of a is going to be the negative 2. And since we're a negative value of a, our parabola is going to be opening to the left. We also want to make note of the fact that our vertex point is going to be located at an x value of the opposite of what we see inside here. So we're going to have an x value of negative 2, and our y value is going to be positive 3. So I start out at negative 2, positive 3 with my vertex point. And I know I'm going to be a parabola that's opening to the left. So I'm just going to give myself a little indicator that I'm opening to the left there without committing to a width yet, because I need to determine the length of my latus rectum and where is my focus and all these other things first. I know that my focus point is going to be located a units inside the parabola, or in this case, really the absolute value of a. We're talking about a distance inside the parabola. So I want to go 2 units inside. Knowing that I open to the left, that means I'm going to travel 2 units to the left here to get inside the parabola. That's going to put me at the ordered pair now, negative 4, 3. So my focus is at negative 4, 3. My directrix line is going to be the same 2 units, but this time I'm going to go onto the back side of the parabola. If my axis of symmetry is a horizontal line, and it would be if I was a parabola opening left, because I'll be symmetrical about a horizontal line, then my directrix is going to be perpendicular to that, or a vertical line. 2 units on the back side of the vertex point. So I'm going to go 2 units to the back, and my directrix line is essentially going to be the y-axis, or the line x is equal to 0. So we know our focus point and our directrix point. Now we need to find 2 ordered pairs on the outside of the parabola that will dictate the parabola's width. And those 2 ordered pairs are going to also be the end of the latus rectum segment. Now remember that the latus rectum is going to have a length that is 4 times our value of A. We could even wrap that up in absolute value bars if you like, knowing that it is a distance or a length of the line segment. The value of our latus rectum, or the length of our latus rectum, is going to be 4 times our A value, which is situated right here. Essentially 4 times -2 is -8. So we want a line segment that is 8 units long. Now that line segment also has to pass through the focus, so we're going to travel 4 units up and 4 units down to get the total of 8 units long. So 4 units up, we're going to go to the ordered pair -4, 7, and 4 units down, we'll go to the ordered pair -4, oops, that's a positive 3, -4, -1. Okay, so these are the 2 that dictate the width of my parabola. So now I'm going to finish it up. I have my focus, which is situated inside the parabola, my latus rectum, which is 8 units long, connecting 2 points on the outside of the parabola and passing through the focus point. I have my vertex being the ordered pair -2, -2, +3, and my directrix is the vertical line x is equal to 0. So I've found everything that I was asked to find. So another example, we're asked to graph this parabola and find all of the information that's listed. I know that this is a parabola because I have, of course, 2 variables, but one of them is being squared. Just one variable is being squared. Since I have the x variable being squared, I understand that I'm going to be a parabola that's either opening up or down. If my y variable was squared and not the x, I would know that I was a parabola opening either to the left or to the right. But it's not in the standard form of the equation of a parabola, so I need to do some algebraic manipulation to this thing first before I can see the vertex point and find the focus and the directrix. So I want to isolate my x variables and get x squared plus 6x is equal to 4y minus 1. And I want to complete the square on the left-hand side, so I'm going to add 9 to both sides in order to get a binomial quantity squared on the left, which is going to be x plus 3 quantity squared. On the right, I'm going to have 4y plus 8, and I'm closer to the standard form, but I'm not quite there. On the right-hand side, what I want is a binomial in terms of y that's going to have a coefficient of positive 1. So I want to factor this coefficient of 4 out and write it like x plus 3, 4 times y plus 2 here. And now I'm in the standard form of the parabola. Notice I have a coefficient of a positive 1 on my y variable on the inside of that parentheses. Now I can see that I am indeed going to be a parabola that's opening up, and as well, my value of A is a positive 1. Alright, so we're ready to graph our parabola. Okay, so my vertex is situated at the ordered pair -3 and -2. So -3, -2 is my vertex point down here. Let's do this. I am going to travel a distance of 1 unit inside the parabola. Now I know that I'm opening up, so inside the parabola is going to be 1 unit inside here to get to the focus. So my focus point is going to be situated at the ordered pair -3, -1. And 1 unit on the back side of the parabola is my directrix. So my directrix is the horizontal line in this case. Y is equal to -3. So my vertex was -3, -2. Like this. Okay? One other thing that I need to do is to determine the width of the lattice rectum, and the lattice rectum is going to have a width of 4 times my A value, which is really situated right here. It's going to be 4 units long. So if it's 4 units long and I pass through the focus, then I'm going to go 2 units to the right and 2 units to the left to get to the ordered pairs. Let's see, -1, -1 here, and -5, -1 here, and my parabola is going to pass through these ordered pairs, leaving me with a lattice rectum point, or distance, of 4. So my vertex was there, my focus, I erased the point, but the focus is located at the ordered pair -3, -1. My directrix is the line y is equal to -3, and my lattice rectum is a length 4.